All right, Mimi, you're live.
Good morning, good afternoon. Aloha to everyone joining us for the Women in Space Exploration Talks. My name is Mimi Fuchs, and I'll be hosting today's presentation with Jane Poynter. We are so excited to have Jane with us today. Before we go on to her presentation, we just want to give a few thank yous. Thank you so much to Pisces for hosting this really wonderful outreach opportunity for us all. And thank you so much to our sponsors, the Hawaii Science and Technology Museum, and of course, Microsoft. I believe I'll be handing it over to Rodrigo, who will give us an introduction for Jane. So we'll give him just a moment to do that.
Thank you, Mimi. Aloha, everyone, and welcome to the second day of the WiSE Talk series. We have a very special guest today, and it is my honor to introduce today's speaker, Jane Poynter. I have known Jane for almost 30 years now. Yikes. She can be described as an adventurer, an explorer, a true scientist, a published author, and a successful entrepreneur. She participated in sample collections and the construction of Biosphere 2, and she was member of the first crew that spent 2 years inside. It was there in 1992 that I met Jane for the first time, and we've been good friends ever since. After Biosphere 2, she co-founded 3 very successful space companies: Paragon Space Development Corporation, Worldview, and recently Space Perspective. She is a role model to women who want to become entrepreneurs in advanced space exploration. I hope you all enjoy her talk, learn from her experiences, and ask her questions. You are in for a treat today. And with that, I turn it over to Jane. Jane, it's all yours.
Awesome. Rodrigo, thank you very much, my friend. So great to see you. And hi there, all you wise women and men. So yes, we are going to go on an adventure today. I am going to take you to the edge of space and even to the sea. And I'm just trying to figure out if you can you see this, Rodrigo?
Yes, we see you. We see your slides.
Okay, excellent.
Perfect.
Awesome. So I have thought about space and looked at the stars for a very long time. One of the very first experiences of having my breath taken away by seeing the expanse of the sky was at sea in the middle of the Indian Ocean on a research boat. Actually, we were crossing the Indian Ocean at walking speed, but that is a whole other story. And I remember one of the my crewmates was saying, you know, it's funny, every night I see these clouds come up above the horizon and they go across the sky, always in the same place. She had never seen the Milky Way before. And we had the privilege of seeing it every night in its full glory. And it was then that I really began to feel viscerally deeply in my bones that we live on a planet, that we really live on this globe in the cosmos. And that was really the beginning of my pull to space. And this is the kind of view that I'll be talking about in a few minutes that we are going to be giving people. I will say the stars are a little stylized here, but the general view is what we will be giving people when they go up with us on Spaceship Neptune. But before we go there, let's go back a bit as well and talk about the project that Rodrigo and I were involved in, because it really did form the foundation of what Tabor McCallum and I, Tabor is another biospherian, as we call ourselves. Tabor McCallum and I really have been on this journey together to create this experience going to space. So Biosphere 2, for those of you who do not remember it because it was a very long time ago that Rodrigo and I were involved in it, was back in the early 90s. 8 of us went inside for the first mission to live sealed inside Biosphere 2 for 2 years. And the entire system was closed tighter than the International Space Station. So it was really sealed. And we were recycling all our air, all our water, grew our food, And it was in many ways a prototype space base, and frankly is still today the most high fidelity, fully functioning space base with a full life support system and for long duration space flight that has ever been built and operated. And there is an aerial view of it. The next slide shows you what all of these various bits and pieces are, but it's just a little over 3 acres, which was, you know, you could really talk all day about this particular project and how we made that completely sealed. And there's a picture of us going in 1991 to begin our 2-year journey. And so here's the layout of the world that we inhabited for 2 years. So you can see the human habitat over there on the left, and the farm where we grew our food, the rainforest, a savanna, a desert, an ocean, a marsh. You know, it was really something. It was really a mini world. And I will remember my favorite place was sitting on the beach and looking out the window at sunset, and around the Biosphere in the distance were the Catalina Mountains, and at sunset they're bright red. And for all the world, we could have been on Mars. So I would sit there and look out through the space frame and imagine myself in a Gerard O'Neill space castle. It was just really quite a magnificent experience. One of the seminal experiences of living inside Biosphere 2 was that of being viscerally part of my biosphere. And on a day-to-day basis, I was really aware that the plants around us were providing us with our oxygen that we breathed, that we were providing the CO2 and the care for the plants inside there. You know, the sweet potatoes that we were making were made from my breath, and then I was eating so many sweet potatoes that I turned visibly orange, and so I was literally becoming part sweet potato. So I really had a visceral experience of being part of my biosphere. And it turns out that this is really akin to the experience that astronauts have when they see Earth from space. It's from a very different vantage point. They're seeing our planet from the outside looking in. We experienced it from the inside. And it was really an astounding experience, and one that has really formed the foundation of the company that we have today called Space Perspective. And for fun, I threw this picture in. I should have put one in of you, Rodrigo, as well, because of course we have them. So this was us before going into the Biosphere many moons ago. So this is the test module that was 1/400th the size of the Biosphere, and it was what we used, excuse me, it's what we used to do a lot of the early research on it. What's really cool today is that it is now, you know, the University of Arizona now runs Biosphere 2, and they're revamping the test module so many years later so that it is actually being used again for space research. In fact, there's John Adams from Biosphere 2 getting ready. They're doing some testing on it, and they're going to start experimenting it very soon, which is super cool to see this continuing work that's going on at Biosphere 2. So when I came out of the Biosphere, one of the big questions we had is, can you know, we just created a single Biosphere. You know, can we have multiple Biospheres that are reproducible, that we can use for living systems? And I designed a system that went to the International Space Station. And the longest duration flight we did was 16 months on the International Space Station. There's Yuri just having unloaded it from the Progress module, where it then was put on the wall of the SPESDA module for 16 months, where animals went through the first time animals went through multiple life cycles in space, which was super interesting and exciting, and also really validated that you can have sealed biospheres as life support systems for organisms over long duration. I've now had an aquatic biosphere, small closed ecosystem, completely sealed for over 20 years with no exchange with the outside at all. and it still has breeding populations of organisms inside it. So one can envision having these biospheres on other planets. I will say there's a lot of work to be done to really be able to put a biosphere on another planet such as Mars and have it really reliably support life, but it is certainly something that I would love to see happen and is seminally important for long duration spaceflight. Rodrigo mentioned a company that I co-founded with Tabor. Tabor is there on the bottom left and top left, who was in Biosphere 2 with me and is in the company that we've started now. This is sort of a smattering of some of the projects we did with Paragon. We started it actually from inside Biosphere 2. I think it was possibly the first company, I can't prove this, but I like to think of it as the first company ever started over the internet with people that I'd never met in person, because this was back in the early 90s when the internet really didn't exist. So the company is still thriving today, growing like gangbusters, and we have technology just flew to the International Space Station for water recycling, and with technology soon going to the moon. We have SpaceX, Orion, Dream Chaser, just about most we've been involved in some form and another in just about every human spaceflight vehicle out there. One of the incredible projects we were involved in and led was taking then Google executive Alan Eustace up to 136,000 feet to become the highest flying human under a space balloon. He also subsequently space dived back to Earth, breaking the speed of sound, free fell for 5 minutes. Quite something, an incredible project to be involved in. But what's wonderful about it was that it has this great place in history, because way back in the 30s, people were thinking about this exact project. You can see there on the bottom left, it's exactly what we did, which is totally cool. So many years later, it took us all that time. So you're not going to ever see a spacesuit with rollerblades on the front anymore. In order for us to complete testing in an airplane, Alan had to jump repeatedly out of airplanes, and we had to push him out. So in order to do so, we put rollerblades on the front of his spacesuit. And on the right there is the safety diver. They were just amazing, making sure that Alan was always safe on every jump he ever did. And even on his record-breaking jumps, when we took him up to 136,000 feet, there were safety jumpers in airplanes that jumped out at the time as he was coming down at that altitude. There is an image of him at 136,000 feet, just after having released from the balloon. And I think here is a video, a really quick video that sums it all up. This is in Roswell, where we launched. There he is under the balloon on the launch pad at the airport in Roswell. As cool as a cucumber, I will say. His heart rate did not get over 65 the entire way up. Quite something is that, Alan. There he is waving at everyone. So that entire thing is the balloon. So when it's near the ground, the lift gas is compressed, and then it grows to its full at altitude. It expands to fill the entire balloon. You just saw a picture of the balloon, a reflection of the balloon in the helmet there. He's in free fall here. And as I mentioned earlier, he free fell for almost 5 minutes, broke the speed of sound, opened his parachute about 12,000 feet above ground. And I will say this was his most balletic landing. He was fine. And it was a glorious day having him as Blicky's safety diver coming in. So that was an amazing day. And there is the team. That is the entire team that did what we called StratX. The project was called StratX. Really something, and that really set us up well to do what we're doing today. But I thought it would be interesting to go back even further and look at who are a couple of seminal women in this space ballooning world. So back in the 30s, Jeanette Piccard became the very first woman to reach the edge of space. And I am proud to say she was the pilot. Her husband was the scientist, which is awesome. And then Vera Simons was really something as well. So Vera Simons in the 50s was the person, she's really the reason that we have space balloons today. She took cottage industry. I mean, something that was a little haphazard and turned it into a reliable method of manufacturing these enormous space balloons. Now, these balloons are the size of a football stadium when they're fully inflated. So you can imagine what it's like to manufacture something like that. And she was the person who figured that out. She was also in her own right a fantastic aviator, flew these space balloons herself as well. So a couple of women were exceedingly important to the history of space ballooning and what we're doing today. So today, Tabor McCallum and I are founders of a company called Space Perspective. This is an artist rendering of our Spaceship Neptune. So that is the full size of the balloon compared to, that's actual size of the balloon compared to the size of the capsule at 100,000 feet in this instance. And there's an image of the capsule. It will have 8 passengers and a pilot on board. There we are over Florida, looking out over the Bahamas. And here is an animation to give you a sense of what this flight will be like. You know, we're really making the safest, most comfortable, most accessible way to go to space in Spaceship Neptune. That pointy bottom on the bottom of it is really important as we splash down, as I'll show you in a minute, the concept of operations. And the view out the window is going to be amazing. And it truly is as gentle as that. When you're flying these space balloons, it is just unbelievably smooth and gentle. You're going to space at a roaring 12 miles an hour. So you're basically going at cycling speed to space. And this gives you a sense of the flight profile. So it takes you about 2 hours to get up to the edge of space, 100,000 feet. We're planning to have people up initially a couple of hours and then bring them back down. It'll take another 2 hours to get down, splash down where the ship will pick everybody up and the capsule, the balloon, the reserve descent system, and bring everybody ashore. So it's about a 6-hour experience. And this shows you that every seat in the house is the best seat in the house, of course, with 8 seats, as I mentioned. But let us not forget that every true self-respecting spaceship has to have a bar, which of course this does. And if you have a bar, you need a loo. So there's a loo, which when in the left here, you'll see the roof of the loo is deployed, so somebody can actually be using it. When it's not being used, that roof comes down. So the center of Spaceship Neptune is completely flat and open for people to walk around in. And of course, there'll be Wi-Fi, and this will also be set up for research as well. We can put payloads all over the outside. We'll have payloads in the pressure vessel as well. And there's a lot of really exciting research that we can do, both human-tended and as rideshare. So we're really looking forward to working. Well, actually, we have a research payload on our upcoming test flight that we're calling Neptune 1. We have a test flight coming up in just a couple of months, roughly speaking, where we'll be taking an unpressurized capsule through the entire flight profile, which is super exciting for us. Our operations center is at Kennedy Space Center, which is where I'm talking to you from now, right over here at the center line of the shuttle landing facility, which we also anticipate doing some of our flights from, which I think is going to be extraordinary for our customers, really exciting. It's really a dream come true, actually, to be here right on Kennedy Space Center. It's super cool to be here every day. And there's an image of us on the launch pad just before launching from the shuttle landing facility, and then an artist rendering of launching from KSC. And so to end up with, we are going to be doing this all around the world as well. And we envision having flights from Alaska, Northern Europe, to be able to see the Aurora Borealis, which would be amazing. And possibly Hawaii, which would be amazing. What an incredible view. There's some marvelous places we can do this from. So super excited for the future, and would really love to take your questions.
Jane, thank you so much for such an incredible presentation. I personally am so inspired, and we've had so many questions coming in that shows
Hold on
that.
a minute. I'm just trying to figure out how I unshare, which is a really, how do I unshare this? Why can't I see the control panel?
We have control now.
Okay, you have control. Excellent.
Yes.
Sorry, carry on.
So we have a lot of questions for you, and for everyone tuning in, thank you so much for being here. And this is your opportunity to ask Jane anything you'd like about her career, about her work, how she got where she is, or any advice she might have for aspiring scientists, entrepreneurs, and engineers. So if you have a question, please ask questions using the question and answer chat window. We have about half an hour to discuss with Jane, and I know we're going to get to talk a little bit more about so many of the exciting things she hit on in her presentation. So to start us off, Jane, you have this incredible career that's really spanned so many different facets of human space exploration and what it's going to take for us to get to this next stage of humans thriving in outer space. And you actually started with this Biosphere experiment. And so would you mind telling us how you initially got involved to be part of the Biosphere and what it took to be to apply? How did you get selected to be a part of this mission?
Well, I actually got involved completely by accident. I backed into the Biosphere training program. The training program was in many ways unorthodox, but really quite effective. I guess I would say it was more of a selection process in a sense. So I was out, I mentioned at the very beginning that I was on a research boat. And I was on a research boat for actually in total a year. Tabor McCallum was on it for 2 years, and it was Biosphere training. I was also in the outback of Australia working on a cattle station for a couple of years, and it was Biosphere training. And what these two very different projects have in common is that they put us in these very remote locations with small teams of people where we were completely reliant on ourselves and each other and very much out in the elements. Both of them were incredible experiences to be involved in. And when I went to them because I was fascinated in the projects themselves. I heard about the projects first. And then I was told, yeah, you should apply to, this Biosphere too. And I'm like, what? And everybody was, so this is really a cool part of the legacy of Biosphere 2. At the time, most of us were spelling the word Biosphere. Like people would, we would be asking people, to get involved in the Biosphere, whether it was to sell us something, design something, whatever it was. And at the time it was all by phone and fax. Whoa, this great technology came along called the fax that was really helpful. And we get on the phone with people and we go, like, you were from Biosphere 2, and they go, bio what? We would literally spell it down the phone. And what Biosphere 2 did was put not just the word, but the concept of biosphere, and that we all inhabit a global biosphere. It put that concept in the vernacular. And I think we all now know what a biosphere is in general terms. And really Biosphere 2 did that for us. And so I jumped at the chance when I was able to get involved.
I mean, it's Exactly as you say it. I really feel like, as someone who grew up learning about the biosphere and about other experiments for humans to experiment with these closed systems, I mean, it was an incredible pioneering event. So we actually have another question that speaks to that. You showed us the slide that showed us that the biosphere really does have all these different climates and landscapes that we might see here on planet Earth. And so what was the reasoning for that? Was that for research purposes? Was that for resource production to make sure you had enough food and that there was the right proportion of oxygen and CO2? Or was this mostly for a psychological relief to make the inhabitants feel like they were still on Earth?
So one has to reel back time and go back to the very early 80s when we were designing the Biosphere 2. In 1982, I was at a conference where Buckminster Fuller basically threw down the gauntlet to the team and said, you guys should do this. You guys should build a biosphere, which is then, you know, Ed Bass and the team picked it up and ran with it. What was fascinating at the time was we, humanity, knew a lot about how to understand what's going on in ecosystems. We were beginning to learn how to repair ecosystems. Nobody that we could find really knew how to build a brand new ecosystem from the ground up. We were asking incredibly basic questions like, if we're going to build the world's first biosphere, what is that? How do you define it? How do you define what a biosphere is? And so we looked at the only biosphere we knew, which is Biosphere 1, the planet we all inhabit. And so looking at it, you know, the first thing you see is that energy comes from outside. In this instance, it comes from the sun. It has many ecosystems, and it's a complex ecosystem that is, you know, fully recycling. It's essentially materially enclosed. That's how we defined the biosphere. And so then we use Biosphere 1 as the model. And Biosphere 1 has many different ecosystems. And, you know, I think we all now know today that if we were really only designing a biosphere or a life support system for us to live on the moon, or, you know, for short-term habitation on Mars, we wouldn't need all of these different ecosystems. But we were thinking long-term. We were thinking, if you're going to literally go build a colony and actually live forever on Mars, what would you need? Oh, well, you probably need more than a farm. You really eventually are going to want to have all these things. So I will say that there was also a really exciting second goal to the biosphere, which in many ways has become the primary goal today at the University of Arizona. And that was really to use Biosphere 2 as a test tube for life so that we can really understand more about our planet. And so having all of these different ecosystems in there was also a way for us to really understand more about planet Earth.
Thank you for that. And that actually leads really well into this next question I have, which is that you mentioned that the University of Arizona is actually starting to repurpose this test module that was used for the Biosphere experiment, and that it's about 400 times smaller than the actual footprint of Biosphere 2. Could you just remind all of us why we need to have these kinds of facilities, why we need test modules and the utility they can provide us?
Yeah, so that was the very first thing that we built out of the Biosphere in 1986, somewhere in there. And we were asking some really fundamental questions. So I think I mentioned that it's like over 3 acres, and it ended up, the Biosphere 2 itself was over 3 acres and ended up being sealed tighter than the space station. One of the original challenges was, how are we going to seal this? You've got a glass and steel structure. We want as much sunlight coming in as possible. We're in the Arizona desert, but anywhere you put this, you're going to have diurnal cycling of the thermal environment, which is going to then, change the thermal expansion of the material. So you're trying to put steel to glass, and how do you make those come together? And then we've got this whole atmosphere that's inside there. And what are we going to do with this atmosphere as it expands, as it heats up? So the test module was originally designed to test the sealing methods and also what became known as the lungs of Biosphere 2, which were the variable volume chambers. So there were two bellows basically attached to Biosphere 2 that we tested with the test module. And it was designed to take up the expansion and contraction of the atmosphere on these diurnal cycles, basically like a balloon on the side of the Biosphere. And then once we had answered some of these really basic questions about how we were going to design and engineer the Biosphere, we then needed to start testing the living systems. So that picture I showed was one of the tests that we did with people, a person, that was Bernd Zabel, who was on the second team with Rodrigo, inside the test module to do a test of the living systems. So let me just add one more nuance or part to the story about why we do things like the test module. So again, putting ourselves back in the time of history in the 1980s when we were designing this, it was the very first time anyone had stepped into a completely hermetically sealed container surrounded by plants and soil and bacteria and insects. And part of the science community and the medical community were concerned that the person that went inside was going to succumb to all of these bacteria, that they were going to become dead of the triffids, and they were going to overtake the thing and seriously harm the individual going inside. That's how little we understood what we were doing with these biospheres at the time. I mean, it was amazing. And in fact, we had, medical officers who refused to be medical officers for this in the beginning because this was so new and was so little understood. So the test module allowed us to really understand some very basic parameters about putting humans into these living ecosystems inside a sealed container.
And it's really incredible to see how far we've come in terms of the ways that we're starting to do more and more of these tests in these closed loop systems. It is really just incredible to reflect on where it began, really. Gina, I was really inspired by the beginning of your presentation. When you said something that I think spoke to myself personally, I think it spoke to a lot of the people who are tuning in today, that they just feel so incredibly inspired by thinking about the universe and our human ability to explore it and learn more about it. And personally, this led me to work in telescope operations and help observational astronomers. I'm curious if you could speak a little bit about how this interest of yours and how this passion of yours ended up with you working as an entrepreneur in the field. I think there's a lot of people who think, if I want to learn about space, I have to be a scientist, or I would have to be an engineer, and maybe wouldn't think about the fact that entrepreneurial activities could really meet their interests. So if you could speak a little bit to that, I think a lot of people, I'd certainly be interested, and I know we have a few questions about that.
Well, I think today, especially being a space entrepreneur, as I like to call myself, because it's such a cool title.
And that's what you are?
Right, exactly. Being a space entrepreneur, is kind of de rigueur now. I mean, back when we started Paragon in our 30s, literally I had just turned 30 when we started Paragon. And I mean, people looked at us like we were such a joke. Seriously? You haven't been in, the space world for 20 years, come back when you've, got a few more gray hairs. So it was really interesting. But of course, now what's awesome is that commercial space is just roaring. There's so much activity going on in commercial space, which I think is really pointing the way for people in all sorts of ways. Initially, we've got piles of people piling into the rocket arena. Okay, that's not for everyone. But now we're beginning to get into, the ecosystem of the space business world is really filling out. So now people who have ground-based companies that are providing services to all of these other commercial space companies are really beginning to take off, which there really wasn't that much option before. So, you know, the whole space world, you know, I really think that in order to get involved in space, you can have almost any background. My background is ecology and agriculture. So if you can get into space with ecology and agriculture, honestly, I believe you can get into space with almost any background.
I totally agree. I always felt like we need all kinds of skill sets and all kinds of backgrounds in order to push forward our understanding of outer space and how we can possibly thrive in these inhospitable conditions. So I also agree. I always tell folks if they don't know what they want to study, they should just study space science or astronomy. You have to have a little bit of everything in order to succeed in the field.
You know what's really cool though? So I think space science, astronomy, and all of that, of course, goes without saying. What's really cool though is that even if you're from the arts, you're from the social sciences, you know, all of that now is really important. You know, marketing, all of that is just so critical to the space world now. So I really do mean that people of a broad range of backgrounds can become really valuable assets to the space industry.
Absolutely. And I think that those opportunities are only going to continue to abound as we see more and more commercial space enterprises. Can I ask, were you ever nervous about starting these new business ventures or staking yourself as an entrepreneur? Were you nervous?
So, I don't get
to that question, sorry, we have a couple questions specifically asking about this. If you were nervous, how did you overcome it, or what advice would you give to people who are maybe nervous about establishing their own business ventures, or maybe their own projects? What advice would you give them to find themselves?
You should be nervous. I mean, starting a business is not, you know, it's not for the meek. So absolutely, if you're not nervous, you haven't thought about it hard enough. And so I think the advice I can give you, first off, is get comfortable with getting uncomfortable. Because it doesn't go away. You're always a little nervous as you get to the next level. Because, you know, as entrepreneurs, we're always pushing ourselves. We're always exploring the boundaries of our capabilities. We're always pushing to find that new opportunity that we can explore, which ipso facto means we're going into the unknown and doing things that other people haven't done. And that is going to make us feel a bit uncomfortable at times. And that's just part of the course. That's part of being an entrepreneur. So if you're feeling nervous, that's normal.
I really love that you say that, to become comfortable with the uncomfortable. I think regardless of what you're doing, like you said, if it's visionary, if it's exciting, it's bound to be uncomfortable and it's bound to be nerve-wracking. And that is not a reason not to do it or not to pursue it.
Yeah, I mean, look, I think I would say that, you know, I wish somebody had told me early on that you need a really good support system around you. I think that can be really healthy for people, because I think as an entrepreneur, one gets all consumed with what one's doing, building one's business, helping your staff, building your team, you know, all of those things that we do day to day. And it's critically important to have a support system that's outside the company. It's really important because it forms, you know, a sounding board, foundation, you know, love, family, you know, all of that. It's just so important to help bolster us, particularly during times that are difficult, and there are always difficult times as an entrepreneur.
Totally. You have to find your people who are going to provide, and as you said, both support for the work you're doing to be able to review it and help provide that kind of feedback, but also in terms of our emotional health. We're humans who need others to thrive, and So we need to find folks to help support us when it gets tough. I think that's really important to remember. So you mentioned that, that Paragon started even when you're in the Biosphere as one of your early entrepreneurs ventures. And I'm wondering if you could speak to how you got inspired to take on some of these other challenges. Like with taking Alan up in the balloon, what prompted that in the first place? And we also have a question about that is asking how he was able to break the sound barrier, and like, was that a goal of the attempt of this specific project? How did it come about?
Okay, so there's a whole lot in there. Okay, so let's talk about StratX. So Tabor and I had been looking at starting a space tourism company and using these space balloons for that purpose, because it does provide such accessibility. And one day, Tabor got a call from Peter Diamandis, who said, "Okay, Tabor, I know you get these kinds of crazy calls all the time, but you have to take this call and you have to listen to this guy. He's the real deal." And so an hour or two later, Alan calls up Tabor, and sure enough, Alan was saying, "Yeah, I want to go to the stratosphere, which is the part of the atmosphere where we're going. And I want to really create a system that allows us to do the equivalent of scuba diving in the stratosphere." And thus StratX was born. And we would not have done StratX with just anyone. I mean, he was interviewing us as much as we were interviewing him, because we took it very seriously that we had his life in our hands as we were taking him up under this balloon in our systems, and that he was coming down at the speed of sound, and we had to make sure he was safe and came back to his wife and 2 kids safely. And part of that was making sure that he as an individual was going to be calm and would do the training and wasn't going to freak out. And Alan is a real mensch. I mean, he's somebody who, I think I mentioned, his heart rate didn't get above 65. So, and he took the training really seriously, and he's an engineer's engineer. So he was with us, all the way. And he was an amazing person to work with. Fantastic. I mean, he was really a member of the team. And breaking the speed of sound was an outcome, not a goal. So when you're falling from the stratosphere from 136,000 feet, the edge of space, you're essentially in a vacuum. And so there's no resistance. And so he reached the speed of sound very quickly. And so when you hit the speed of sound, you're going over 800 miles an hour. And then as he started interacting with the troposphere, which is the part of the atmosphere that we all walk around and fly around in, the atmosphere starts getting thicker and thicker, and that's when he started to slow down. So then he slowed down just from the friction from the atmosphere, just from going through the thick atmosphere that we're all in, that we breathe. And that allowed him to slow down enough to where at 12,000 feet above the ground, he could open his parachute.
I mean, it's just so incredible. It kind of goes along with the saying of, it's just so crazy, it just might work. And I think it's a phrase that a lot of folks can apply to commercial space ventures in general, because these ideas are so exciting, and yet they're outside of the realm of imagination for a lot of us, at least in this current day. I absolutely see that changing in these next coming decades. And I think that's one of the reasons that I myself was so excited, and why we got so much of an excited response to when you were talking about your work with the space perspective and with Spaceship Neptune. It is just so exciting to think about this becoming a reality. So would you mind talking to us a little bit more about the status of this project? So where is Spaceship Neptune right now? What is the testing schedule? And like, what do you see as the dream milestones for when we'd be able to book a ticket? So we already have folks wanting to apply to be the bartenders. I'm assuming that's all of our 21 and above participants. So yeah, if you could just lay out a little bit more for us to understand where Spaceship Neptune is right now testing.
You bet. So yeah, so one of the really cool things you mentioned that, for so many people, space flight is still a thing of imagination, still a thing of sci-fi. And what is so cool about being here at Kennedy Space Center and doing Spaceship Neptune is that we're seeing sci-fi today in reality, right? And with Spaceship Neptune, we are going to be starting our test flight campaign in a couple of months. And that is going to be an unpressurized capsule that we have a fun surprise with. And we'll be taking that up through the entire flight profile. And that will really be the first test of this particular concept of operations. What's really cool with what we're doing is that we get to build on technology that has got such a long history to it. I mean, honestly, it goes all the way back to the 30s with this sort of basic style, and NASA has flown this kind of balloon thousands of times. We've flown it hundreds of times. So we have a lot of experience with this kind of balloon, but this particular concept of operations and flying something this big is new. So that's the start of our test flight campaign in a couple of months. So then we leap forward to when we start having our first crewed flights. We're planning roughly 2023, and then commercial flights starting in roughly 2024. And one of the cool things about this technology, about Spaceship Neptune, that I think you would appreciate, is that safety is, of course, absolutely paramount for our customers. And so the technology is inherently safe because it's been flown so much, but we also get to fly it autonomously. So we get to fly this vehicle hundreds of times. We have already flown it hundreds of times, and we're going to be flying it through all kinds of off-nominal scenarios, like, come up with these crazy things that could happen, and make sure that our design that our team is doing really has all of the backups, really test all of these redundancies and backup systems in things that you could never do with people on the ship, because it wouldn't be safe. And so we're really able to put Spaceship Neptune through its paces. So we're the safest way to get to space, which we're also super excited about, because it just really increases the accessibility, and we want to see thousands of people going to space.
I do too. It was really exciting to hear that you see yourselves doing these test flights in the next couple of years. I started thinking that it was a little bit longer term. So I can't wait to see what's next. That is just so exciting.
Well, to give you a reference, StratX took us 3 years from a drawing on a napkin to breaking the record, and we had never flown a balloon before. So we know how to fly balloons. We've done all the manufacturing. We've basically done every part of this before. So that gives you context of why we're pretty confident on this timeline.
That is incredible. What a short window from design to the successful. I was going to say launching, but I don't know if that's really the appropriate word to describe exactly what Alan did. Jane, we just have a couple more minutes, and I was hoping you could end with one final question. Throughout your talk, we've seen the different products you've been involved with that have been related to humans being able to thrive in inhospitable conditions that we'll find ourselves as we advance in our space exploration missions. And I think something that you said that was really incredible was that when you were in the biosphere, you came face to face with your own immediate interactions with yourself as a human who constantly is interfacing with the environment around us. And we talked a little bit about how the biosphere experiment kind of introduced this concept to society, that we are constantly exchanging with our environment, and if we're going to thrive in inhospitable regions in the universe, we are going to have to find ways to overcome that. I was wondering if you could speak a little bit about this for folks who are tuning in who maybe think that commercial space ventures aren't relevant to them. Maybe they think it's something that is going to be far off. Maybe they can't afford it yet. But I was wondering if you could speak to this idea of what do commercial space ventures do for the average human here on Earth? How could they potentially improve our lives here on Earth?
Oh my gosh, how much time do we have? You know, I mean, the space industry writ large, we wouldn't have this without the space industry, right? So, you know, we wouldn't know where we are on this planet without the space industry. You know, we wouldn't know what's happening to the Amazon rainforest without the space industry, right? So, you know, and that's satellite imagery and all of that, right? All of the instruments that we fly. I mean, I think you can think of space in many ways as a skin of sensors. It's like we've put all of these sensors around planet Earth, around our biosphere. You know, and we use that for many different purposes, but one of the purposes we use it for is to understand our planet as well. So, you know, the reason that we know what's going on with our atmosphere is in part due to what's going on with our satellite imagery and the sensors that we've flown. So, you know, that's that. And then on the human side, you know, I really think that flying humans to space on a repeated basis, an increasing number of people to space, is going to have a huge societal effect that I think most of us don't understand yet. Anybody that has talked to an astronaut will know that almost all of them are deeply moved by the experience of seeing Earth in space. And not only are they deeply moved, it actually has been shown to change their behavior. I mean, almost all of them come back getting more involved in environmental and social causes. You know, so one could say that, you know, one of the things that we're doing is offering people the opportunity to have that extraordinary experience. And some of them are going to get deeply moved by it and come back and do great things. And some of the things that we're doing is also involving artists, students, scientists, writers, musicians, right? So we want to involve people of all sorts so that they can experience this in different ways. They can communicate it in different ways, explore it in different ways, and then make the world a better place for all of us.
Here, here. I agree with you. I truly believe that space exploration and our ability to meet its extremely daunting demands is only going to improve our life here on Earth. Jane, thank you so much. Thank you so much for such an incredible presentation. I am so inspired by everything that you have talked about, and I really can't wait to see the next steps with the space perspective and with Spaceship Neptune. Thank you so much for your time, for your presentation, and for your very thoughtful responses to our questions. Thank you to everyone who helped make this outreach experience possible. A huge, huge, huge mahalo to Pisces for putting on such an incredible outreach experience for us all. Big thank you to the Hawaii Science and Technology Museum and Microsoft for helping sponsoring this event. And don't forget, the WiSE talks are going on all week. And so tomorrow we'll be joined with Dr. Veronica Bindi from UH Manoa, and she'll be presenting on space weather and space radiation for future human space missions. And again, there'll be a 30-minute presentation followed by a question and answer session. Again, my name is Mimi Fuchs. It's been such a pleasure to host this presentation with you all, and hopefully I'll see you throughout the week. Mahalo and a hui ho.
Thanks.